Welcome to this presentation in which we will derive a prediction model for GPC. We will write the prediction model over an interval. We will collect the equations and organize them. Let's recall the Aric's model. Here is the original model. This is how we divide C by A into EJ and FJ. C is 1 of course here. In the place of A we have A delta, and this is the prediction error model. Now we will define this EJ into B as GJ, and we will indicate that these are polynomials. Recall that even though we write Z, these are polynomials in Z inverse. With this definition we get, instead of EJB we get GJ, and everything else remains the same. What are the degrees of GJ and FJ? Let's take GJ first. Degree of GJ is degree of EJ plus degree of B as given here. We will denote the degree with this letter D. Now let us add these two. First we will add the degree of EJ, and that is going to be J minus 1. Recall that's how we got this. We divided until J minus 1 and all other terms had Z power minus J or higher degrees. So we got this plus degree of B, and degree of Fj is, because this is a reminder, the degree of Fj will always be 1 less than the degree of A delta. So we have degree of A delta minus 1. This information will be useful in the subsequent slides, and if I substitute for delta and A, so this will be degree of A plus 1, because delta is a degree 1 polynomial, it is given by 1 minus Z inverse. So I add 1 for this delta and then minus 1 here, these two cancel each other, I get degree of A. So we need to remember this. So I write this down here. I have written it in blue. I would want you to note this down. We will require this frequently in the rest of the slides in this presentation. Now let us write the expression for GJ. It is going to be a polynomial in Z inverse, and it will go all the way up to J minus 1 plus dB, of course powers of Z inverse. So we get this term that has a coefficient Gj. So let us write this y hat of n plus j. The first term is Gj0 into this term here, which is delta u n plus j minus k. The next term will introduce a Z inverse. So I put a minus 1 here, and the coefficient is Gj1. I go on adding this all the way up to Gj dj into this expression. Of course, the easiest way to understand this is if you add, for example, 1 with this, you get n plus j minus k. Here also if you add 0, you get n plus g minus k. Here you have dgj is given here. You just add this, once again you will get n plus g minus k here also. So that is a way to verify that these indexes are correct. Similarly, we write the expression for Fj into y of n. So Fj0 into y of n, and then Z inverse comes, so minus 1 all the way up to degree of A. So you get this also. What we will do is we will stack them up and split them as future inputs, past inputs and past outputs. Some of these could be past, some of these could be future. So what we will do is we start with the prediction model as given here, and I have written only the G delta U terms here, expanded them. F terms I have not expanded, I have just kept them as F, I want to concentrate only on this. In the next slide, we will look at the F term. Okay. Let us substitute different values for j equals k, so it becomes n plus k. So here it is k0, when I substitute j equals k, it cancels this k, so you get delta u of n, then n minus 1 and so on all the way up to a term of this type. You can verify that this expression is indeed correct, plus f terms. So I have not included that here. Let us do the same thing for k plus 1. So we have terms of this type, and here you can see that it will increase by 1 here, k plus 1 here, k plus 1 and so on. And the way to remember is n plus 1 plus 0 is n plus 1, here n and then 1 here, second index, it becomes n plus 1. Similarly, if you add this, you will get correct terms. Of course, you have to substitute for dB from the previous slide. You can continue with this and arrive at all the expressions. Okay, I would want you to make sure that you get all these terms. Now let us stack this up for different j values from this. For example, using this, we will obtain y hat of n plus k, y hat of n plus k plus 1 and so on, like in the previous slide, but stack them as given here. So this is gk0 into delta un. This was the first equation in the previous slide and so on. And of course, some more terms are here that I am going to write separately. The reason is whatever I have written here can be written as G into vector u, whereas this matrix is G, and these terms denote future control moves. These are the values that we need to use, whereas the next ones, whatever I have not included here, which I have collected separately, are the past control effort delta u of n minus 1. So once again you have to verify this multiplied by this plus this multiplied by this in the first row will be the same first row we had in the previous slide. It is just bookkeeping. There is not much theory in this. It is straightforward. Only thing is you have to go through this and make sure that you agree with this representation. And just like we represented this matrix vector product as this GU, we write this matrix vector product as H1 into U underscore old. So this old denotes past values, this U underscore denotes values that are yet to be calculated. Notice that although I have delta here, I do not write delta here. It is understood that whenever I write U underscore, I have to use this vector. Similarly, I have to use this vector for the old. We have still not included F terms. We will calculate them in the next slide and add that to these two. Okay, and we usually predict over a longer interval. That is, for delta u we said we will go up to n. Here, although I have written it up to k plus n, typically we write many more terms. So we usually predict over a longer interval for this y, which results in a taller matrix. In other words, this is not a square matrix. Usually it will be a taller matrix with more number of equations than number of unknowns. Remember, this is the one that is to be calculated in the future. Okay, now we will look at the f values. So what are the f terms of this future prediction? So you can see that you can get this expression. We call it H2 y old. These are the previous values. In fact, it is straightforward. for example, Fk0 into Yn, which is this, and then Fk1 into Y of n minus 1, which is this, and so on. So you get this first equation by substituting j equals k, and then when you substitute j equals k plus 1, you get the second row, and so on. Once again, you have to convince yourself that this expression is indeed correct. In the next video, I will be presenting an example, and I would suggest that you take that and check out that you indeed get this prediction error model. Okay. So here we get H2 Y underscore world, which denotes this whole thing. In the previous slide, we had these two, G underscore U plus H1 U underscore world. So we have to add these two, we get this. So the definition of Y hat U world and Y underscore world are obvious. You have to pick them up from this slide and also in the previous slide. To conclude, we predicted Y values over an interval, we stacked them up, we arrived at a vector equation. Usually this is a tall system. We split this into future and past values. We will use this prediction model in subsequent lectures to design GPC law. That will be explained in subsequent lectures. With this, we come to the end of this presentation. Thanks for joining. Goodbye.